A very warm welcome, my dear children. We are in the part 2, fourth lesson, metals and non-metals. Part 1, we have seen different physical properties of metals with the help of few activities. So from that we concluded that metals possess some physical properties such as metals are hard and rigid, whereas metals are malleable, metals are ductile, metals are sonorous, metals are lustrous in nature. Now we are going to see the next property. Metals are good conductors of heat and electricity. For that, you need to make an activity at home. Looking into page number 45, activity 4.2, we shall start this activity. We know that conductivity means passing electricity or flow of electrons. We call it as conductivity. In the previous class, we have discussed that the mother cooks food in the metal vessels. We say that metals are good conductors of heat. And now, let us make out an activity whether metals are only good conductors of electricity and how non-metals react with this. So, for that all we need is a battery, 2 wires, aluminium foil, iron nail, coal, graphite, any other non-metal, sulfur. So now let us make out the circuit. Set up an electric circuit as shown in the figure 4.2, which we call it as an electric tester. Test the following electrical conductivity by just joining the 2 wires, one end of the battery positive terminal and one end of the battery negative terminal. Connect one terminal to the bulb which is connected to a nail with the help of a wire, and that wire is connected to the other end of the battery. Now just switch on. You can see when you test the electric circuit with a metal such as iron nail, aluminium foil will glow. This says that metals are good conductors of electricity. Now let us see with the non-metals such as sulfur, coal piece and copper wire. You can see that iron rod, nail, copper wire are good conductors of electricity, while rolled sulfur piece and coal piece, even there also the bulb glows, children, not only in the form of metals but with the non-metals also bulb glows, but very poor conductors of electricity. So we say that metals are good conductors of electricity, whereas non-metals are poor conductors of electricity. Sulfur piece, in the case of sulfur piece, the bulb does not glow. So with this we just say that non-metals are bad conductors of electricity, whereas graphite is an exception. Why? Because graphite contains carbon. Carbon is a good conductor of electricity and heat. So let us see with the next property. You observe that where do you find the use of aluminium and copper wires, children? Have you seen wires of coal? Definitely not. The property of the metals, which it can be rolled into wires, thin sheets or thin layers of wires, we call it as ductility. This one we have seen in the previous session itself. So just I want to make you to remind. I would like to bring you to the notice of 2 special metals in the periodic table. Metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is found in liquid state at room temperature. These are the exceptions in metals, children. That is, sodium and potassium are highly reactive, highly explosive. So these metals are very soft. At the same time, they cannot be stored in the open place. They always can be stored in, must be stored in the place containing coconut oil or kerosene or petrol. And they are so soft so that they can be cut with the help of a knife. And mercury is called as a liquid metal. Now we are going to the next part of a lesson, chemical properties of metals and non-metals. In that we first learn with the reaction with oxygen. You are familiar with the phenomenon of rusting of iron. When an iron nail is placed in the moist atmosphere, you can see that the metal gets corroded. This corrosion is taking place on the upper layers of the metal. The best examples, children, the olden toys which you have played at childhood, or you can see a small cycles. Bicycles also get rusted. You had performed these activities in previous earlier classes. So let us see another example of reaction of metals with oxygen, that is magnesium ribbon burns in air. Take a white colored magnesium ribbon. When it is burnt in the air, you can see it burns completely and it forms magnesium oxide. This example, you can see a white colored ash will be formed when magnesium reacts with air, that is magnesium reacts with oxygen to form magnesium oxide. Magnesium symbol is Mg, children. For oxygen, you will write O2. 2 Mg plus O2 gives rise to 2 MgO. Let us see one more reaction. Iron reacts with oxygen and water to form iron oxide. Yes, we will see these reactions which we call it as rusting of iron. Rusting of iron is learned. We have seen this from our childhood, but we don't know what is the chemical reaction so far. So, when an iron metal is placed in the atmosphere, it reacts with the moist air to form iron oxide, that is Fe2O3 plus XH2O. We are learning about the equation of iron. We call it as corrosion, children. Corrosion means oxidation has a damaging effect on metals as well as food. So, in corrosion, we call it as oxidation of iron metal, or whichever metal may be, we just say it as corrosion. It is the process in which metals are eaten up gradually in air and moisture. Rusting of iron metal is the common form of corrosion. We also say it as oxidation of metal in other form. When an iron object is left in the moist atmosphere for a considerable time, it gets converted into red browny flaky substance. We call it as rust, and this process we call it as rusting of iron. During the corrosion of iron or rusting of iron, iron metal is oxidized by oxygen of air in the presence of water to form hydrated iron oxide, that is 4Fe plus 3O2 plus 2x. X means, children, molecules of water, that is 1 molecule of water, 2 molecules of water. 4 moles of iron reacts with 3 moles of oxygen with 2 moles of water to form iron oxide or hydrated iron oxide. We call it as rust. 4Fe plus 3O2 plus 2H2O gives rise to 2Fe2O3 XH2O. X stands for number of moles of iron oxide. We call it as rust. So this is how iron gets rusted. Whereas Mg, magnesium plus oxygen, O2 gives rise to 2 MgO. When we take 2 moles of magnesium with 1 mole of oxygen, it forms 2 moles of magnesium oxide. Let us see activity 4.3. Let us check the nature of rust formed as a result of the reaction between iron, oxygen and water. Collect a spoonful of rust and dissolve it in very little amount of water. You will find that the rust remains suspended in water. Shake the suspension well. Test the solution with red litmus paper and blue litmus paper. What do you observe in this solution? Here children, you have to understand that red litmus turns to blue when tested with bases. Blue litmus turns to red when tested with acids. If the solution is neutral, they does not change the action of litmus, color of litmus. So you can observe this. You have been observed that as the solution just turns red litmus paper, so we say that metallic oxides are basic in nature. So it turns red litmus to blue. Now recall the activity of burning of magnesium ribbon. The ash obtained on burning magnesium ribbon is dissolved in water and tested for its nature. In this solution, we just say that magnesium oxide also is basic in nature. You must have observed red litmus turns to blue in the case of magnesium oxide and rust, everything. So in general we say metallic oxides are basic in nature. Have you ever seen a silver metal gets rusted? Yes children. Now look at your anklets. You can see the day one when you brought it from the shop, it has a very shiny nature, lustrous nature, and it is white in color. As the days pass on, you can see the silver gets tarnished. So rusting of silver, we call it as a special word called tarnishing of silver. You can also see it becomes black. So that we call it as oxidation of silver or tarnishing of silver. Have you ever seen copper also gets rusted? Yes, I can see a greenish deposits on the surface of copper vessels. When the copper vessel is exposed to moist atmosphere for a long time, it acquires a dull green coating. The green material is a mixture of copper hydroxide and a copper carbonate. So the reaction is when copper reacts with water, that is H2O, carbon dioxide CO2, and air contains oxygen. So air is a mixture of several gases along with humidity. So when copper metal is exposed to moist atmosphere, it forms copper hydroxide CuOH twice and CuCO3. When you test this also with the litmus paper, you can see red litmus turns to blue. We say that all the metallic oxides are basic in nature. Children will meet with the next part of the lesson in the next class. Thank you. Please go through the textbook and learn those 3 equations. I repeat once again. Magnesium reacts with oxygen to form magnesium oxide. Iron reacts with water, oxygen to form iron oxide, that is Fe2O3 XH2O, which is the formula for rust. And copper reacts with water, carbon dioxide and air, oxygen to form copper hydroxide and copper carbonate. All the metallic oxides and hydroxides are basic in nature. Finally, we conclude that metallic oxides are basic in nature. In the next class, we shall start with the reaction of nonmetals with oxygen. Thank you.